Oh my goodness. Y'all. Students, welcome back. We're in lesson 18. Miss Tracy just needed a brain booster. I had to get me a Reese's Peanut Butter Cup. These things they're my favorite. Just FYI. If you want to get anything for Christmas, you can put that on your list for Miss Tracy. The Reese's Peanut Butter Cups. Sometimes when you do a lot of math, your brain starts to get a little bit sleepy. And sometimes a Reese's Peanut Butter Cup or one of those mini chocolate bars is just the right size, the right amount of sugar to give your brain a little boost. So I give you permission, if you need a little piece of candy right now to give your brain a boost so you can do your math work, pause the video and go get you a little snack. And then come back and listen. We are in lesson 18. And we're going to talk about like terms and the addition of like terms. Okay? So we know what terms are. Terms are these things right here. They're the coefficients to each other. You have a constant and you have a variable. In this case, this one has a constant and two variables. Here's a constant and here's a couple variables. So these are all terms, right? Sometimes we get terms that have an implied similar value. What I mean by that is, we might have a number sentence that looks like 4x plus 3a plus 2x plus, let's say, 3a again. Okay? I'll say 13a, just for the sake of having a big number. When you have a coefficient and a variable, we call the variable the base. When that variable is similar over here and here, when they're the same, we can actually combine them together. We call those like terms, and like terms can be added together. Let me show you what I mean. Let's say, for the sake of argument, that x is equal to 2 and a is equal to, a is equal to 1. We'll just say 1 because that's an easy number to do. All right, so if we added these two together, we would have 6x, right? And if we added the 3a and the 13a together, we would have 16a, right? All right, so that would give us a value. 6x would actually be 6 times 2, so it'd be 12. And 16 times 1 is 16. That's our final product of these. Let's see if we can sub them in and come up with the same thing. So that would be 4 times 2 would be 8, right? And 2 times 2 would be 4, right? 8 plus 4, that's 12. Haha. 3 times a being 1, that's 3. 13 times a, that's 13. That's 3 plus 13 is 16. So because they're alike, we can condense them and get the same result. So that's how we can look at these terms, and when we have this big long list, we can actually do some math with them. So for instance, if I had 4 and x and p are my variables, minus 2p mx plus 6 mxp, do I have like terms? How can I simplify that? Well, remember back to your commutative property of multiplication. These are factors. These variables and this constant within this term, these are all factors. We can rearrange factors in any order we want, and it's still the same value. It still has the same intrinsic value regardless of what order you write it in, right? Remember, 2 times 3 is the same as 3 times 2. So what I like to do is I like to go back and put these terms in alphabetical order. I mentioned that in the last lesson, and that helps me to see which ones are alike, okay? So 4, and then M, and then P, and then X, okay? 2, right, I have an M, I have a P, and I have an X. Okay, and 6, oh, I have an M, and I have a P, and I have an X. Wow, so these all have the same factors, so that means I can do some math with the constants. So 4 minus 2 is 2. 2 plus 6, that's 8. So 8 MPX is the answer for this. I was able to combine these terms based on the constants. And that's what you can do. You want to look and see if the variables are identical in each of the terms. And if the variables are identical, then you can combine the constants based on their positive or negative signs, just like you would a normal whole number. Okay, why don't we practice some of those? We've got 5 practice problems. So I'm going to clear this, and let's start with 18.1. And I'm going to go through a couple, and then I'm going to get you to do a couple. All right, so we have this. Actually, let me pause this, and then I'll write it, and then it'll be faster for you. All right, so I've written the problem for you. It's 3x plus 5 minus xy plus 2yx minus 5x. All right, so now we need to look and see what we have that are similar terms. So the first thing I see is I have a 3x and a negative 5x. So let's combine them. So positive 3, negative 5, it's going to be a negative 2x. So I got that one. Now when you get them, when you combine them, it helps to cross them out. So you know you've taken care of it, right? It helps to make those marks to keep it straight in our head. We don't have to hold everything in our head. We want to make sure we get it right. All right, so I only see one of these, just whole numbers by itself. So I'm going to cross it out and write it down here. That's the only one like that. All right. Now what I have left, I have a negative xy. And listen, if you have a negative and just variables, put the number 1 right here. Because we understand in mathematics that the 1 is often invisible. Especially when you have negatives, put that 1 right there so you can see that it's a negative 1. Because 1 here does not change the value of this, because 1 times anything is just itself, right? We know that. Our 1 times tables, it's 1 times anything is just itself. So put that 1 right there. It doesn't change it. It's still going to be negative x when you're done. But that helps us to do some math. We can take negative 1 and this positive 2 and combine them. It's easier to see that in our heads. So that's a tip from me to you. Drop that 1 in there and you'll see it better. Okay. Now we have an x and a y here and a y and an x. It's the same variables. They're just in a different order. That's okay. Because when you combine them, you can write them in any order you want. What we need to do now is combine our constants, negative 1 and positive 2. That's going to be a positive 1. Now, when you write this, you can write it as positive 1 xy, or you can write it as xy. Because remember, the 1 is invisible. So if you have an answer that has 1 and some variables, you don't have to put the 1 there. But if putting the 1 there helps you see it, put it. It's up to you. Either way is correct. I don't care. All right, if it's correct, it's correct. And that's your answer. That's as far as you can go. So this has an x and this has an x, but this also has a y. And because they're multiplied against each other, they are not the same value. Okay, this has a factor that this one doesn't have. So we can't combine them at all. All right, let's do 18.2. All right, 18.2, I've written it out for you. 3xy plus 2xyz minus 10yx minus 5yzx. If you need to pause and write that down, you can do so. So one of the steps, or one of the things that you can do if it will help you to identify your like terms, I mentioned it before, you can rewrite the problem in by putting the variables in alphabetical order. So if we do that now, we would have 3xy plus 2xyz, that's already in alphabetical order, minus 10, and we'll rearrange that, xy, minus 5, and that should be xyz. All right, now we can see what our terms are, right? And it's important that you keep the symbol or the sign of that term with it. So this is a positive, this is a negative, right? This whole thing, you keep it together. So we're combining these four terms. So the 3xy and the negative 10xy have the same variables. So we combine the constants. 3 and negative 10 is negative 7xy, right? So now we have a positive 2xyz and a negative 5xyz. Those are the same variables. So we can combine the negative 5 and the positive 2 and get a negative 3xyz. That's your answer. That's all you can do. Okay? You see how simple that is? You're just looking for the same combination of variables and combining the constants that you can match up with the variable. All right? So I'm going to write, let me clear the page, pause and copy if you need to. I'm going to write out 18.4, I'm sorry, 18.3 and 18.4, and I'm going to get you to work them for me. All right, so I've written out 18.3 and 18.4 for you. What I'd like for you to do is pause the video at this point and solve these, and then as soon as you solve, you can press play and see if you got the same answer that I did, see if you got it correct. All right, so if you're ready, number 18.3, we had a 7 mxy, and then we had plus 3 yxm. Well, those are the same variables, they're just out of order. So we're able to combine the coefficients of, the coefficients, the constants of plus 7 and plus 3, or positive 7, positive 3, to get a positive 10 mxy, because they have the same variables. And then we had a whole number of 4 and a whole number of 5 added together because they're both positive. That's 9. But then we had a negative 15, so that's going to be a negative 6 or a minus 6. So this should have been what you got for 18.3. And if you did that, congratulations. Now moving on to 18.4, this one was a little bit longer. So follow along as you can. So we have here a positive 3x. We know it's positive because there's no negative sign in front of it. So positive 3x, but over here we have a negative 3x. So those cancel each other out. Plus 3 minus 3 is 0. Right? They're opposites of each other. So we could just get rid of those and not do anything. So we only have one x left, and it's a negative x. So we just bring it down. We brought down our negative x right here. Now I'm looking at this negative y, and then we have a negative 2y. So negative, remember you can drop a 1 in here. Negative 1 plus a negative, or combined with a negative 2 is a negative 3. So that's negative 3, and then we have a negative 8y over here. Negative 3y, negative 8y, that's a negative 11y. So we got all that. Now all we have left was a positive 5 and a negative 10. Well, when you combine those two, you get a negative 5. So that's all of it. And none of these are all combined as much as we can. None of these are like terms. So this is our final answer for 18.4. So if you got that in any order, it doesn't matter what order you got this in. If you got negative 5 minus x minus 11y, still correct. If you got negative 11y minus x minus 5, still correct. What matters is the individual term, a negative 11y, negative 5, and negative x. If you got those three terms in any order, then you got that problem right. Same thing up here. If you got negative 6 plus 10 mxy, same solution, it's just in a different order, and that's perfectly acceptable. I try to do a good job of giving you all these options so that the system will match it up to what you put in there. I tell it to check for the math equivalent, and usually that will find those differences in order. If it does not find it and it marks it wrong, rest assured I check everybody's work. And if I see a situation like this where the answers are correct, they're just in a different order, I'm going to mark it right. So don't worry as much about the system, and the grade that you get for your homework, it's not the final grade until I say it's the final grade. So I will check it and make sure that the system isn't marking something wrong when it's actually correct. Do your best work and trust me more than you trust Jupiter Ed, because it's just a computer. It can only do what we tell it to. So if I don't type in every variation, it may miss one. So that's on me. But if I see it, I will get it right for you. That being said, we're going to clear the page, and we're going to do the last problem, which is 18.5 together. All right, this one's a doozy. It's a little bit long, but we are going to do this together. So let's look first for our whole numbers. Usually that's the easiest ones to do, so we can get them out of the way. So we have a negative 3 and a negative 5. That's negative 8. And we have a negative 14. So negative 8 and negative 14, that's going to be a negative 22. So we can cross those out. That's a negative 22. All right, so let's look for some more. All right, let's do the easiest term. We have a negative y. Remember, you can sneak that 1 in there. So it's a negative 1, and we have another y term. There's a negative 3. Negative 1 and negative 3 together, that's a negative 4y. Okay, now we have two terms left. We have xmy and ymx. They're just flip-flop. They're the same term. It's the same three variables here as here. And if we sneak our 1 in, we can see that it's a positive 1 and a positive 8. So that gives us a positive 9 x m y. And that is the correct answer. I'll cross those out, show we got those. I really like marking it out because it helps me see where I am. Use whatever tips or tricks that help you. If it helps you get the right answer, it's not a crutch. It's a method. Okay, don't let anybody tell you that, oh, well, I can do it all in my head. Good for you. This means I'm probably more accurate than you are because I'm keeping track of it on paper. When you try to do it all in your head, I'm sorry, it gets complicated, especially when you're trying to juggle some numbers. So use the paper. God made paper and pencil for a reason. Write it down, keep track of it. It is to your benefit. Use all of the resources that the good Lord has provided so that you can do your best and get your best education. Okay? It's not about proving who can keep what in their head. It's about learning and understanding what is presented, and you do what you need to do in order to get that. Okay? And I do it, and I've been doing math for about 40 years now. I still do it. So there you go. It's just easier. It's just, why make it harder for yourself when you have resources? So that's all I have for lesson 18. And that's it. We have a little less than 21 minutes of lesson, and I'll see you in lesson 19.